you folks, these are double angle formulae. So on the left hand side here we've got a big list of both formulae that we've had before in the last section, and then some new formulae now, some double angle formulae. So we know that cos of 2a is ultimately equal to 1 minus 2 sine squared a, and we know sine 2a is 2 sine a cos a, tan 2a is 2 tan a over 1 minus tan squared a. Then cos squared a is half 1 plus cos 2a, and sine squared a is a half 1 minus cos 2a. So these are all again in the log tables, but we just need to be able to use them to do certain things like what's over here in the example. So express sine of 3a, so straight away I know that sine 3a is the same as sine of 2a plus a. So we're going to have, because we've got no formulae with 3a or 3x or anything, so we're going to have to break it down into 2a plus a, and then we can do things with with sin of 2a or whatever, and we can do things with sin of a. So sin of something plus something, we're going to use this formula, the very first one over there. So we know that that is equal to sin of 2a cos of a plus cos of 2a sin of a. So just using that formula there. Now let's break it down a little bit further. So let's change that sin of 2a into something. So if you take sin of 2a, so I'm using the double angle formula now, so that's the same as 2 sin a cos a, and there's already a cos a there as well, plus, and let's change that cos of 2a, so we know that that's the same thing as 1 minus 2 sin squared a. And then there's still a sin a there as well. So we can simplify a little bit now. So we can put those two cos a's, we can put them together and call them cos squared a. So we get 2 sin a cos squared a plus, and then if we multiply in the sin a there, so we get sin a minus 2 sin cubed a. And we're not too far away from being finished here. The only problem we have left is the cos squared a. So how to change that into something? So everything else then is in of sin a. So I'm going to use the cos squared a plus sin squared a is equal to 1. So that's one of the first terms in trigonometry that's in the log tables as well. So if I move the sin squared a across the equal sign there, I get 1 minus sin squared a. So I know that that's the same thing as cos squared a. So I'm going to use that here. So I'm going to put that in instead. So 2 sin a and then 1 minus sin squared a. So now I have everything in terms of sin a. So if I multiply that in, I get 2 sin a minus 2 sin cubed a. There should have been a cubed over there as well. And then you'll notice that we're getting when you've got 2 minus 2 sin cubed a's, so that's minus 4 sin cubed a, and it's just 3 sin a. So everything is in terms of sin there, and that's all you have to do. You just have to put it in terms of sin a. So that's one type of question that you could be asked on these. So if you look at this one then, so given that theta is acute and that tan of theta is a half, evaluate sin 2 theta and cos 2 theta. So we're going to use the double angle formula. So sin of 2 theta would be the same as, so if you use this one here, 2 sin cos a, so 2 sin theta cos theta. So if I was to draw a little right angle triangle here, I already know that tan of theta is 1 over 2, so therefore the opposite has to be 1 and the adjacent has to be 2. So if I just do Pythagoras really quickly here, 2 squared plus 1 squared has to be equal to 4 plus 1, and which is 5, and then if we get the square root of that, so the other side has to be root 5. I'm just using Pythagoras there if you're not sure what I'm doing. So therefore sin of theta has to be it's the opposite over the hypotenuse, so that's 1 over root 5, and cos of theta is 2 over root 5. So if you just multiply those together, then you get 5 on the bottom and we get 4 on the top, so 4 over 5. So that's it, simplified. And then cos of 2 theta, so let's use the double angle formula up here. That's the same as 1 minus 2 sin squared theta. So I know that sin of theta from this right angle triangle over here is 1 over root 5. Therefore sin squared theta, that's just sin theta all to be squared, has to be just 1 squared is 1, root 5 squared is 5, root 5 times root 5 is 5. So I'm just going to get 1 minus 2 times 1 over 5, which is 1 minus 2 over 5, which is 3 over 5. So that's it, that's those two things evaluated. Now the last couple of examples I'm going to do. So the first one there, so you're always just taking what's on the left and you try and make it into the same as what's on the right. So sin of 2a, that's 2 sin a cos a, that's one of the formulae above, over 1 plus, and then cos 2a. So if you look back up the formulae up here, so we're using this one here, but we're not going to use the 1 minus 2 sin squared a. I want to eliminate the 1 in it, so I'm going to use this part. It is 2 cos squared a minus 1, which is the same as the other. We're just manipulating it around a little bit, and we're putting in a, so we're changing the cos squared a into 1 minus sin squared a. But we can put that straight in, so 2 cos squared a minus 1. So the 1's will cancel on the bottom then, so you're just left with 2 sin a cos a over 2 cos squared a. So the 2's then will cancel out, and one of the cos's on the bottom will cancel out with cos on the top. So we end up just getting sin a over cos a. And that's the same thing as tan a. So sin over cos is always tan. So that's it for the first one. The second one, so you'll see the 2 powers of 4 there. So what we actually have to do here is use difference of 2 squares. So that's the same as theta plus sin squared theta times cos squared theta minus sin squared theta. So that's using difference of 2 squares. So just look back at difference of 2 squares, and it's just using it with cos and sin in it. And it's actually simple enough from there then. This part here, this cos squared theta plus sin squared theta, that is the same thing as 1. And then the other part is the same thing as cos 2 theta. And then it just simplifies down into what we want, so just cos 2 theta. So that's it then. So that's just 3 examples of where you have to use them. So you need to really think about them when you see the question, and try and look at what formulae or what bits you can use to try and make it look like the thing you want on the right. So it's not that easy sometimes, there's a lot of formulae there to look at, But just keep trying things and subbing things in, and you should be able to get them or simplify them down in the end.